Good afternoon. Thank you for joining us for the webinar. I see people still signing in, so we'll give it additional 5 minutes before we'll kick it off. So we'll kick it off at in about 5 minutes from now. People are still joining the webinar, joining the session, and we'll start in a few minutes.
Good morning, everybody. Thank you for joining our webinar, How to Add Tens of Thousands of New Gigabit Subscribers at the Speed of the Light. My name is Eran Sagi, and I'm the Head of Marketing at Ciclo. I will host the webinar today. Before I introduce you to our presenter today, just a few logistics. If you have any question during the webinar, please feel free to send it to send us the questions via the chat option, and we will respond during or at the end of the webinar. So I would like to welcome Boris Meisel, our presenter today, the Head of Business Development at Ciclo. So Boris, please take it from here, and everybody, enjoy.
Thank you, Ron. Thank you, everybody, joining us this afternoon. Depends on your time zone. I'm pleased and glad to have such a large audience despite the last-minute changes that we had. And first of all, I'd like to apologize on all the changes with the registration. Actually, we should have been hosting this webinar session together with the fiber broadband communities, and due to some their internal reasons, they decided not to participate. Despite the high number, hundreds of registered participants that are willing to learn about this technology and about how to add these toolkits to their these tools to their kits. So in any case, we'll conduct this session. We'll have additional session probably next week for those who couldn't join us. And this session is going to be recorded and available together with the slide deck on our website. And feel free, of course, to connect to us and send us emails, ask questions. We'll be glad to have a discussion later on. So the way this session is going to be conducted today, I have some slides to share with you for about 30 minutes, and we'll have a Q&A session. After that, you can send your questions here in the dedicated area in the webinar, and we'll refer to all of those questions at the end of this session, and we'll follow up with you in case the question wasn't answered. So we'll begin, and so we are going to talk today about a lot of numbers. So it's not 5G blah blah, and there is a big hype around 5G and fixed wireless access. So today I'd like to focus on numbers, a lot of numbers, business cases, real deployment, real scenarios, and I truly believe that this session will be helpful for you as a service providers to deal with real problems. So the agenda is we'll start from the latest and not so greatest situation about the wireline carriers, what the main challenges are, and we'll get to the solution of this problem. Actually, how to stop the churn, how instead of losing customers, add new customers, and the answer to that is actually a combination, what we call hybrid fiber wireless. So I'll show you why just fiber is not sufficient to deal with that, and why wireless is not sufficient. And though we are a wireless company, in fact, our wireless solution, enable new fiber, and they help to monetize the already existing fiber, leverage the asset, leverage the value of the existing fiber. So we are here to talk about the combination, the hybrid fiber wireless approach, how to combine fiber and wireless in order to deal with the challenges of the wireline carriers. Next topic is actually the unicorn. So I'm based in the Silicon Valley in California, and actually there are a lot of unicorns are all over the place here, and we are going to talk about where the unicorn of the connectivity. So I'll share with you the numbers and talk about the opportunity where to start applying this hybrid fiber wireless approach in order to unlock this multi-billion opportunity for the connectivity market. And we'll also review some practical examples, different use cases, different scenarios of this topology, of this solution, and we'll be open to questions. So we'll start from review of the current state of the broadband market here in the United States. As you can see, the main challenge of the wireline carriers is that they lose customers. Quarter after quarter, they experience high churn and lose customers. In particular, the ILECs, the small service providers. And these small service providers are the most vulnerable ones. And the thing is that the competition is just going to increase because of the MSOs, because of the cable guys. They have DOCSIS 3.1 that they started to roll out. And using this technology, they will be able to provide gigabit or close to gigabit services. The big carriers like Verizon and AT&T, they are looking into the 5G space, where the first application of the 5G will be fixed wireless access, and they will be able to provide services, broadband services to homes, to residential customers, to business customers, and this will increase the competition for those small carriers. Those small carriers, they struggle with the old and costly DSL infrastructure. They are using this old DSL infrastructure. They are just unable to provide competitive services. And the question is, what can be done? What can be done in order to solve that? And we believe that the answer to that is a combination of existing fiber and millimeter wave. So this approach will help them to fill the gap between the fiber that they already have, or the core fiber that they started to deploy, and provide gigabit services, extend this fiber, and provide gigabit services to the end customers. Now, the situation with the fiber is the following, and actually I couldn't find a better advocacy for HFW approach than this chart. So this chart was presented in Fiber Connect conference this year in Orlando by the Fiber Broadband Association. And what you can see here is that the dark blue chart is number of homes marketed, and I refer to that as the number of homes passed, because it doesn't make sense to market a home if it is not home passed. So when you can see a clear trend for the recent years, that the number of home passed is growing. So there are more and more homes that become close to fiber, that become accessible or potentially accessible to fiber. But the pace of the homes that are being connected to fiber is actually not increasing. So the gap between the homes passed and the home connected actually increases. And some of the numbers, so today we have, according to this chart, about 14 million homes connected, and the pace of home connected is about 1 million homes a year here in the States. And assuming that there are around 1 million homes here in the United States, it will take us 90 years to connect to the rest of the homes, and we'll definitely get there in case we won't die from global warming. So the bottom line, or the punchline of this chart, is that the core actually is fast and furious. So the fiber that is deployed in the core, the technology is there, and actually more and more homes become more home passed, but the drop is not there. And probably the reason for that is that the drop cost is still very high, and the deployment is very slow. So I think that this is exactly the opportunity for millimeter wave technology and for high broadband, high speed wireless technologies to fill this gap, to help the core fiber to get to the edge of the network and to connect the homes. So this is how visually it should work. So the fiber is there, okay? So the fiber gets to the building, and then from those buildings that are connected with fiber, this fiber can be extended to additional buildings, additional locations, and there are different topologies. So there are some technical issues which I will not cover during this session, but it can be the millimeter wave can be used as an aggregation point. It can be used as an access. It can be used at the rooftop. It can be used at the street level. So once this building, for example, has the gigabit connection, so this building can serve additional buildings and also can serve other street level locations. For example, provide backhaul or provide connectivity to Wi-Fi backhaul, to security cameras, all those smart city applications. So we call it building as a platform. Once this building is connected, it can actually provide more use cases or enable more use cases in this specific scenario. Now, once this topology is in place, this fiber actually serves all those customers. And at some point, you may realize that this building here is a bottleneck, but you already know the business case for that. You already know the number of customers that are connected here. And making a decision to bring fiber to this building, actually, it simplifies that. So you know exactly the number of paid customers, you know exactly the business case numbers. And in this case, mmWave wireless technology enables new fiber. Now, some practical example or some example from the field, you can see here, it's a snapshot of San Francisco. So some of our technology, and we'll talk about some properties of the mmWave. So as you'll see, some of those technologies are lightly licensed. And it means that the links, the radios should be registered. And this is taken from publicly available database that is hosted by FCC. And these are public numbers, and these are our radios in San Francisco. So you see that within a time frame of just 4.5 years, there are thousands of buildings connected. And in fact, the denser the network becomes, the lower the cost per home connected is, the better the performance is. And these are the basic properties of this type of technology. So you can see that in the mid of 2017, there are almost 3,000 homes that are served in the downtown San Francisco area by this technology. Now, can it be done without fiber? No, because there is no way to provide gigabit or multi-gigabit capacity without having fiber core in place here. Can it be done just with fiber? Probably not as well, because the speed of deployment, the cost of deployment, the barriers of entry, the coordination processes in downtown areas just will not allow fiber to be expanded as fast as this type of technology. Now, San Francisco is not the largest city in the United States. It's actually the 13th largest city. So imagine how it will look, or how it looks like in New York, in LA, in Chicago, and other areas. So at this stage, I assume that I convinced you that the combination of fiber and mmWave wireless is the right thing to do. And you probably know about fiber. You're familiar with that better than I do. But what mmWave is? So I try to keep it simple. There are two basic facts or two basic properties of the mmWave. And we in C-Crew are focused on the P-band, which is the 60 gigahertz unlicensed part of this mmWave spectrum, and the E-band, which is the 70-80 gigahertz lightly licensed part of the spectrum. So in V-band, first property is that there is huge amount of spectrum. In V-band, last summer, FCC opened additional 7 gigahertz of unlicensed spectrum. And actually, it became the largest available frequency band here in the United States, with 14 gigahertz of unlicensed, free-to-use, accessible spectrum, which actually more than all other bands, sub-6 bands, traditional microwave bands, other licensed mmWave bands put together. So this is a huge amount of spectrum, free to use, and a lot of spectrum means a lot of channels and a lot of capacity. So this is something that is, this technology utilizes highest bandwidth that is available in order to provide gigabit or multi-gigabit capacity. Another property is that those frequency bands are virtually immune to interference. And this comes down to the physical properties of these frequencies, the narrow beam antennas, the propagation. So it is mainly used for last mile communication. So the distances that we see are about 2, maybe in some cases 3 miles, but that's it. So it is really the drop. But when the network becomes denser, the distances become shorter, so and the performance increases. And you've seen that in the previous slide in the example of San Francisco. So actually, the performance doesn't degrade using these dense deployments, and actually improves. And this is the main difference, for example, of this band comparing to sub-6. So in dense urban environments where the spectrum is congested, it doesn't. This band doesn't care about that. So you can deploy dense network and still be able to provide gigabit service. Now, millimeter wave is not a new technology. It's a field-proven technology and is actually widely used, widely deployed today. And we see in the FCC database that I've mentioned, 75% year-over-year growth on average in the number of links registered here in the US. So this technology is being adapted rapidly. We work closely with more than 80 cities that use millimeter wave for smart city applications. And a few months ago, Facebook announced that they managed to conduct a trial, that they managed to transmit 36 gigabit per second in E-band using single radio. And on the right-hand side of the slide, you can see big service providers, small service providers, internet giants, all of them use this technology. So it's field proven, it's already deployed, and there is no risk with this in this regard. Now, continuing to, so we understood how this technology combines with the fiber. We now understood the physical properties of this technology, what can be achieved and what is challenging for this technology. So it has been able to provide multi-gigabit capacity, immunity to interference, but it's line of sight, and it is a really last mile solution. Now, what is the main opportunity here for the service providers? And if you look at the US census data, and you start to do some analysis on that, you'll see that from all hundreds of millions of buildings that we have here in the States, 1.5% are MDUs. But on the other hand, though this 1.5% of MDUs of multi-dwelling units with the number of with 5 or more apartments represent almost 20% of the customer base of potential customers. So targeting this market segment of MDUs, which is quite simple with this hybrid fiber wireless toolkit, it enables you connecting several building structures and gaining a lot of customers, and this comes back to the challenges of the service provider to stop the churn and to stop losing the customer. So focusing on this MDU segment is really helpful, and doing some basic math. So there are about 1,500,000 structures, MDU structures with more than 5 units in the United States. And the average number of customers per MDU for those buildings is about 16 apartments, with a monthly fee of just $70, which is pretty much the industry standard for the gigabit connection. And using this HFW topology, you'll be definitely able to provide gigabit service. And with the with adoption rate of 40%, it results in a market segment of $8.3 billion. So it's significant opportunity, and I think all the tools are here to address that. So now we'll look into several examples on how to deal with that, and we'll start from MDU. So I'll focus on small operation, and I'll show you that even with being a small service provider, with the very limited task force and operational force, you still be able to add thousands of customers and millions of new revenues to your bottom line. So connecting 5 MDUs per week will result in connecting in 260 buildings connected a year. With the 50 tenants and 40% take rate, it means 20 customers per MDU. $70, doing the math, it is 5,200 of new customers connected to Gigabit service, and almost $5 million of dollars of revenue stream from just from this application. Sample project that we've designed together with one of the service providers that we work with. It is one of the cities here in the United States, and there are 86 buildings, and we've designed this kind of, you can see that it is kind of a mesh network, but it is, in fact, these are rings, so it's ring and sub-rings. So in terms of the technology and in terms of the technical solution, there is no single point of failure. So this network is resilient, and this is another advantage. So wireless can be resilient as much as fiber can. Now, doing a business case for this project, together with the installation and together with the gear, we came up with the following numbers. So it is almost $6,400 per building connected, and we are talking about pretty much downtown area here, and putting in place in-building connectivity, which can be implemented using Fast. It results in $340 per unit connected. And assuming the revenue stream of $70 and the penetration rate of 40%, it comes down to the 6-month ROI. Now, another point here is that how it connects to the fiber, because this network is impossible to deploy, and it is impossible to provide Gigabit service to all those buildings without having fiber. Now, the decision of making adding new fiber pop here becomes much simpler as well, because it actually doesn't matter where you add a new fiber pop to. So it can be added at any location on this ring, and it will serve this ring and all other rings all together. And for example, if this building here, the number of 65 building, is too costly to bring fiber to because of this is located in the downtown area and it takes a lot of time, you can go off this area and connect this building, which will be maybe faster and cheaper to connect. So it can optimize the fiber connectivity and fiber locations, having this plan well ahead. Now, the next application is garden style, and when I refer to the garden style, it actually complexes, business parks, plazas, and it is also a combined solution of fiber and wireless. So some of those locations are already connected to fiber, but unfortunately, those buildings or those apartments that were built even 7 years ago, they lack building-to-building connectivity. So the building-to-building connectivity, well, may be very tricky and maybe very costly. So here we use point-to-multipoint V-band radio in order to connect the other buildings to the fiber pop or to the fiber that is standard using E-band. So this main building here it can be connected to fiber, or if the fiber is not available, the fiber can be extended from a fiber pop using point-to-point E-band. And today, with the solutions that are available today, it is easy to provide a 10 gig connection to here. And other buildings, instead of digging those properties and those plazas, other buildings can be connected using point-to-multipoint solution. And the in-building connectivity can be done using Gigabit, can be done using Ethernet or Wi-Fi. And there are solutions on the market in general availability today from Calix, from Atron, and we've done from Bacchus, and we've done a lot of interrupts with those solutions, and actually many of our customers already use that. So another point here is that this solution actually can enable additional application, as I've mentioned, building as a platform. So parking lots, so this gigabit connection can be extended to the parking lots to connect cameras, or it can be extended to common areas to connect, to provide the backhaul to the small cells or to the Wi-Fi. So all in all, there are three main building blocks in this solution: backhaul, fiber, where it is available, or E-band that can extend fiber up to 3 miles. The drop is done using point-to-multipoint radios that can provide almost 2 gigabit of capacity, and the in-building connectivity is implemented using G.fast, Ethernet, or Wi-Fi. Next application is a single-family home. So this solution is scalable to serve single-family homes, and these are KPIs from a real deployment. So the cost per home passed is about $300, and home connected $800, which brings the ROI to this kind of project to 8 months. And this is a real picture of installation in the single-family home neighborhood. The same works in urban residential neighborhood, and the installation is simple, just a single cable without alignment. So it is definitely something that can be done using non-microwave skilled technician, and it means that this solution is scalable. So you need to have a fiber pop to feed this kind of network, but the installation, the deployment, the rollout is actually a pretty easy task. A couple of words about Siklu and what we do. So we are the world leading company for the mmWave solutions in the V-band and E-band. We have more than 50,000 installations in more than 30 countries. Our biggest market is here in the United States. Probably between 20 to 30,000 units are deployed here. And coming back to the FCC database. So this is our market share, and today, actually, 2 out of 3 systems that are deployed in the United States are Siklu-made. So we control, and this is publicly available data. It's not market research. It's not analyst report. So this is what we have here, and we serve, or our customers, they provide connectivity to MDUs. This is, I think, the prime usage of this millimeter wave for the hybrid fiber wireless solution. And this is the main application that our solution is used for, and this relates to the fixed wireless access, 5G fixed wireless access, if you'd like to call that. The second one is businesses and in complexes, student housing and plazas, and even single-family homes. That the product, the multi-point product, we launched that in May this year, and we already shipped more than 2,000 units here. This is our product portfolio. So this is the E-band on the left-hand side. This is the E-band radio. It can serve up to, provide connectivity up to 10 gigabit per second. We have 1.4 food antenna version, and 2 feet radio that can go farther. The main use case, or the main installation use case for this type of radio is the rooftops, because of the form factor. Rooftops or towers. The one in the middle is designed for the street level. It's point-to-point V-band radio, mainly used for smart city camera connectivity, Wi-Fi backhaul, small cell backhaul to connect devices that are at the street level. It can go and it can provide capacity of up to 1 gig for a distance of half 0.6 miles. And this is the new product. This is the point-to-multipoint. It can support up to 8 clients. It has the beam steering capabilities, though the beam width is still very narrow, so you actually gain benefit from both ports, since the installation of this product is very simple, like Wi-Fi, but the beam width is still very narrow, so you still have the immunity to interference, the main property of the millimeter wave. So this new product can provide connectivity to up to 8 devices. So this is the sector, really small, 5 by 7 inches, and total capacity for per sector is 1.8 gigabit per second aggregated. The distance that this sector can cover is up to 1,000 feet, so it really is the draw. Another portion of, or another part of our value proposition is the planning capabilities, and this is very important for rollout. We are going to launch the planning tool in beta for friendly customers in the upcoming month. This tool actually helps to design and automate large-scale deployments. So any deployment with more than a few hundreds of units can be automated, and this tool actually takes into account LiDAR data. It can save a lot of money on line of sight, site surveys, etc. It will generate the bill of material. It will generate the performance matrix, and it will generate connectivity diagrams. So it is very helpful. So currently we use most of our design are done with this tool, and this is currently used for internal use. Currently, actually, we use it for our own as our own design tool, and it will be available next month. So just to sum it up, hybrid fiber wireless is about to enable and monetize fiber. So we are not fighting fiber. We are enabling and we are utilizing, adding value to already existing fiber by expediting and optimizing the connection to the end customer. It's like Uber. It's not a replacement for Southwest. You need to have both. In some cases, you'll fly, but at the end of the day, in order to get to the end customer, to the end user, you need to take a cab, take an Uber. And this is exactly the case here. We have a full, complete millimeter wave portfolio, and it enables connectivity to all sorts of structures, and it means that using this portfolio, you'll be able to connect MDUs, businesses, complexes of all sizes, and even single-family homes, and you can match the business case with the right equipment. So you'll not shoot a rocket to kill a small bird. You'll adapt the right solution to the right problem. You'll be saving money, and you'll deploy it faster. And the final thing is that V-band and E-band, those millimeter wave frequencies that we operate at, are free and easily accessible. So you'll not be required to pay ahead hundreds or tens of billions of dollars just to get access to the spectrum. And this is an important thing because the telecom giants that acquire licensed 5G spectrum bands, 24, 28, and 39 gigahertz, paying a lot of money that probably you don't have But in fact, you don't have to pay this money in order to provide the same services that they will be able to provide a few years from now using this spectrum, using this technology, using this hybrid fiber wireless approach. You'll be able to compete with them and provide competitive services like they do, gigabit services, without large investments in, to acquire the spectrum. Okay, so this is it on my side. I'll be glad to refer to questions and Ran.
Yes, Boris, first of all, thank you very much. It was very interesting. We have a few questions that people wrote during the webinar. So let's start. The first one is what is the relation between millimeter wave and 5G? Can you explain a bit more about that?
Yeah, so the 5G is today it's more kind of a marketing term. So at the end of the day, we need to look at the application that 5G is going to handle, and 5G is not a silver bullet of the technology. So there are different solutions for that. There is a fixed part of the 5G and there is a mobile part of the 5G. The mobile part probably will be deployed by the big carriers like AT&Ts and Verizon. But the fixed wireless can be actually deployed and this spectrum 60 gigahertz and 70 gigahertz can be utilized to serve this portion of the 5G fixed wireless access. And as I explained in the last slide, the advantage of V-band and E-band is that this spectrum is easily accessible and you can actually provide the same services like the big guys will be able to provide using licensed bands, but you can do it now and without investment, without purchasing the license, the frequency.
Okay, thank you. The next question is, you talked about, both 60 and 7080, the V-band and E-band, and the question here is, how complex is the process to get the license? Obviously, the 7080 is lightly licensed. How complex is the process to get the license done, and what is the price of it?
Yeah, so here in the United States, the process is very simple. The V-band is unlicensed, so there is no licensing process whatsoever. So you have a need, you can go outside and install that. For the E-band frequency band is called lightly licensed, and it means that you need to acquire a license from the FCC. And the license cost here in the United States is $75 per 10 years, which is really negligible. And the process is automated and everything is done. Everything is online, and you get the license within 24 hours. And you get all the benefits of licensed band. It means that if you got a license for specific location per link, right, 2 points, 2 sites, you get the benefits of being protected. If someone else wants to install a link at the same location, at the same direction, he'll need to switch to another channel. But fortunately, there are a lot of channels available, and it's not an issue. So just to sum it up, for V-band, no license. For E-band, $75 per 10 years.
Okay, great. There are a few people that asked about whether the webinar is recorded and whether we will send the presentation. The answer is absolutely yes. We will send it within the next few days. In addition, we will run additional webinar, similar webinar, probably within a week or two. We'll send another e-blast within the next few days about that as well. So if you want an access to that, you will get it soon. The next question is, what are the additional applications that the millimeter wave is used today beside, I assume, beside broadband?
Yeah, so we actually we see two main verticals that our equipment has been using. One is broadband and MDU businesses. This is what we covered here in this webinar. The other application, and this is the fastest growing vertical that we see from, at least from our perspective, is what we call smart city or safe city. So as I've mentioned at the beginning, the fiber is there. The thing is that it's not dense enough to cover and to provide connectivity to all the all the connectivity um, scenarios or all the connectivity use cases within the smart city. So what we see is that the main use case or the way it starts from is providing backhaul to cameras that are deployed at the street level. So some of the cameras are connected to fiber, some are not, and those that are not are connected using millimeter wave. And actually, there is no other alternative in dense urban environment because the sub-6 band is really congested, and it may work in rural areas, but definitely not in dense urban environments. You just open your cell phone and see how many Wi-Fi networks are there, and just to get a sense of how the spectrum is congested. So uh, uh, except for fiber, the millimeter wave is the only alternative to provide connectivity in those dense urban environments. So it starts usually from connecting cameras, what we call the safe city, and it goes later on, once the infrastructure is in place, it goes to on the same network, on the same network infrastructure. Wi-Fi backhaul access points are connected, small cells, and other sensors. So it is uh, deployed in cities, it's deployed in parking lots, in downtown areas, in ports. We have installation in the Port of Long Beach, which is the second largest port here in the United States. We work with the police departments, NYPD, LAPD, to connect their cameras. So this is something that, so this is smart city, safe city. This is kind of the second use case besides broadband that this technology has a great fit to.
Okay, next question. I think it is related to the MDU business case. The question is the backhaul cost and the IP transit cost figured into this the ROI that you presented?
Yeah, so some of the IP cost definitely is inside, and I also see here the customer acquisition and etc. So yes, some of the costs are taken into account. Also the penetration rate, the in-building connectivity, the installation. So, but there are a lot of details in those business cases. So what I suggest is to have a dedicated session with colleagues that would like to go over the business case. We have tools. We have Excel sheets that we'll be glad to share. So I'll prefer to take it offline. Most of the parameters, though, are taken into account.
Okay, good. The next one is related to our link budget calculators. There is a question, how accurate, how conservative are the numbers that we are presenting with the current link budget calculator?
Okay, that's a great question. So actually, the numbers are based on the performance of the radio, and this is guaranteed performance because we test all the radios over temperature, over frequency. So and we have a span of around 100 degrees Celsius that we support in most of our radios. So the numbers are proven and rock solid. Now you can add the fade margin. So there is a field to add fade margin. Most of the calculations are done with, if I remember correctly, with 2 dB fade margin. But you can be more conservative, and you can add, you can adjust this number to match your requirement. And of course, when resilient configuration has been used, so you can plan for lower availability, but the numbers, the distances that I stated here during the presentation were referred to 4 nines availability. But you have your control over the link budget tool to do the calculations, to do the distance and availability calculations, and you can plug in the number that you feel comfortable with.
Okay. The next one is related whether we have a representation in Colombia and Peru, and in general we have representation in Central and South America. If you have, I prefer to take it offline if you would like to discuss it. So please contact us after the session. There is another question about homologation documents on those units. If we have such, the answer is absolutely. Again, it depends on the country and whether there are regulations in those countries, but we definitely have the required documents in all those countries that we have business with. The next question is a technical one. Do your devices have routing capabilities?
Okay, so first of all, referring to the previous question, we have all the units, all the solutions that we presented here are certified and commercially available. And so we have FCC and ETSI regulations, so it is not prototypes, all including the point to multi-point. This is a general availability. This solution is in general availability. Now referring to the networking capabilities, so our devices, we have in almost all our devices, we have an NPU, network processor unit, and but those devices are layer 2 devices, so they support some IP in terms of some IP capabilities like several IPs and some classifications according to DSCP and some other things that are related to IP. But in general, the devices are layer 2. We may add additional functionality because we have the NPU embedded, but this is something that, and we add a lot of customer particular features to our product, and this opens the door for additional discussion. What IP capabilities do you need? And I'll be glad to discuss it with you on a different offline and to understand the requirements.
Okay, the next one is how the radios are managed and provisioned.
Yeah, so that's a very interesting question. We have different tools to do that. So all the radios support CLI and WebGUI to simple configuration and provisioning. All the radios support SNMP, V2 and V3. We also support zero-touch DHCP. We support authentication protocols, 802.1x. We support also CFM OEM and in most of our radios to performance, to configuration, to operation amendments according to MAF specifications. We support, I've mentioned DHCP, zero-touch, different options of DHCP. So there are plenty of ways, and we use standard MIB files. And operational-wise, we have a single firmware version to support all the radios. So once the unit is integrated into SNMP, it actually can be, the same software version supports all the radios. So it should be very simple and easy process.
Okay, there are two related questions here, so we'll ask them together. How much training is required to become mmWave equipment installer? And the second question is, what is the best way to align antennas, and how hard is it?
Yeah, so it is very interesting question. so the benefit of the discussed of the millimeter wave is that these radios are the beam width is pencil beam width is very focused. The flip side of that is actually the alignment process. However, we made it be aware of that challenge, and we made this process very simple. So we have dedicated alignment mode. All is needed is to plug in a standard voltmeter. So there are no proprietary equipment or test equipment that is needed to align the radio. We have a YouTube video that shows the alignment process, and we have optical tool to make it simple to do the rough alignment. And this is also enclosed with each and every box that we ship. So all in all, after watching a video, which takes, let's say, 10 minutes and doing the first installation, you are good to go. It's not very sophisticated because of the tools, because of the features that we added to the product to simplify this concept. Now, for the point to multi-point, there is no alignment there because it has the beam steering capabilities, everything is electronic, and you just need to point it in the general direction, and that's it. And just plant the seeds or install the terminal unit, the CPEs, and it will connect automatically.
The next question is with regards to the home solution, I guess the point to multipoint, what kind of average upload speeds are you getting per home?
Yeah, so the point to multipoint solution actually the sector provides up to 1.8 gigabit aggregated capacity that can be divided to up to 8 sectors, up to 8 terminal units, sorry. And this allocation is actually a dynamic one. So once the user hits the speed test button, he'll see 1 gig up and 1 gig down, assuming no one else using this network. So the peak capacity that can be advertised using this solution is actually gigabit. In real world installations, we see something between 800 meg to 950 meg. This is what is achieved using point to multipoint.
Another question now about rural. Do you have a rural example where your technology been used, and how did they do the fiber piece?
Yeah, so the sweet spot of this technology is actually the dense urban environment because of the congested spectrum, because of the need in high capacity for rural environments and short distances, right? In rural environments, the specific is that we usually talk about long distances, 5, 7, 8 miles, and the capacity is less than usually demanded in the dense urban environment. Though we have a solution that's kind of a combination between the millimeter wave and sub-6 or traditional microwave radio. And this solution combines two radios, one that operates in the millimeter wave that can provide gigabit or multi-gigabit capacity, and the other one is the low frequency radio that provides few hundreds or several tens of megabit capacity. But the good thing about this solution is that the range of this solution can be extended up to 7, 8 miles. And the way it works, the main limiting factor for the distance of the millimeter wave is rain attenuation. So you actually cannot guarantee availability of beyond 2 nines at the distances up to beyond 3 miles. But having a combination of traditional microwave or low frequency radio, sub-6 radio, which is not subject to rain, will keep the link connected in case of high or medium rain. But most of the time, 99% of the time, the link, when there is clear sky and there is no rain, the link will operate at 2 gigabit per second speed. So this is a solution that we have for rural environments. But once again, the sweet spot of this technology is dense urban. Or once you extend this fiber, or once you bring the fiber to denser area, you can do the drop and densification using mmWave. But the application of long distances, rural environment, is not the natural one for this type of technology.
There is a question here about the difference. What is the difference, or what are the main advantages of unlicensed millimeter wave versus traditional unlicensed sub-6 wireless?
Yeah, so the main difference is there are two main differences. One is that in the millimeter wave, you'll be able to provide much more capacity, and no matter how dense the network will be, or the density of the network that you'll deploy, you'll still be able to guarantee this throughput in dense urban environment, in dense deployment. And this is actually something that will not happen or you'll not be able to guarantee with the sub-6 radios. And even in the areas that in urban environments or in suburban environments that today are not that congested in sub-6, it will become. And the better use of the sub-6 band is to be dedicated to access. For example, Wi-Fi access points. You'll better off dedicating 2.4 gigahertz band together with 5 gigahertz band to the access, rather than use it for the backhaul. Use V-band, which is separated, which will enable you to guarantee the backhaul performance and the capacity to feed this Wi-Fi access point, and use the sub-6 for the access to the end user, to the devices.
The next question is about point-to-multipoint again. Can we limit each terminal unit separately? I mean the speed.
Yes. So there is a rate limiting, and there is also license per terminal. So you can. Yes, you can.
Do you have an example how distribute the cables inside home? Or there is another related question, is what technologies are used for in-building connectivity?
Yeah, so for in-building connectivity, from what we see, there are three main technologies that are being used. Gigabit that can utilize the existing wiring, either copper twisted pair or coax cables. And this is when you consider MDU connectivity, the major portion of the cost is actually in-building connectivity. But using G.fast, you will not be required to rewire the building, and you will be able to utilize the existing cabling. And this is the most cost-effective solution, in my opinion. Some of our customers, they do Cat5, so they connect their end users with the Cat5, and they do rewire with the Cat5. And some of our customers, they use in-building Wi-Fi solutions. There are some available in the market by Atran or by Ruckus, and these mainly three in-building technologies that are available today.
Okay. There's a question whether we have a representation in United Arab Emirates. I don't think we have. Anyway, if you're interested, please contact me, after the webinar. There's a question that I'm not sure I understand it. Maybe Boris, you will. What has been the biggest challenge when ISPs launch with E-band?
So actually, it's a great question, and I think that the main challenge is related to get access to vertical assets, and it can be either rooftop or street level. But at the end of the day, they've managed to do that, and in fact, it is easier to do it as a small service provider. That kind of the perception that you are the guy from the block and you serve your neighborhood, and you care about the service that you provide, and you want to provide gigabit edge cutting, state-of-the-art service to your residents, and then the cooperation from the building owners is easier. Now, we see that building owners, they started to realize the importance of a high-speed broadband connection, because there are more and more millennials going into those MDUs, going into those complexes, and all they care about is not how many channels, how many TV channels that they have, it's how fast their broadband connection is, because they use it over the top, Netflix, Hulu, Amazon Prime, all those services on Sling TV, and all those services require broadband connectivity. So those access rights or rooftop rights, I think it is much easier today than to get access to that and talk to building owners than it was several years ago. And one of the reasons is because people understand the importance of broadband. Maybe there is no particular use case for a gigabit connection service, but there are definitely hundreds of megabits. There are many use cases for hundreds or a lot of tens of megabit services today.
Next, there is another one that is asking about someone that joined the webinar quite late. Yes, the webinar is recorded and will be sent to you. And the last question, will you have documentation available about suggested distribution layouts for small MDUs installations?
Yeah.
Very interested in how others do this. Yes, we'll be at Wispapalooza. We'll have our own booth. We'll have many of our sales guys will be there. So yes, please feel free to contact us there. I think that's all.
I think that it is about time to wrap it up. So I'd like to thank Eran for helping to organize and host this webinar. And of course, I'd like to thank all the participants. We'll put the slides on our website together with the recording of the webinar, and we'll be glad to follow up. You have my contact details in the invite. Feel free to send us emails and questions, and we'll be glad to help you to overcome those challenges and help you build a better network faster. Thank you.
Thank you very much.